Recently, I was very interested in C++ template metaprogramming. The reason being that I was required to implement a state machine in one of my projects. And when talking about state machine, normally this kind of implementation is the most common one that you can find on the internet, where you have a state machine. It contains its state, and the state is a virtual class, has two virtual functions. The specific state, in this case on or off, should inherit from the state, and it requires, of course, then runtime polymorphism. This is, of course, a runtime hit for the performance, if you care about it. And also from the design point of view, each state will take the state machine object, and internally it can change the state of the state machine from the state itself, which in my opinion is a very weird design, and in certain cases it can also be dangerous. So if you are developing a real-time critical application, this virtual function calls can be a consideration for you. And normally you won't see this design in the industrial level software. And it turns out that C++ template metaprogramming solves this problem in a more elegant way. For example, in the Boost meta state machine library, it offers a more elegant solution using template metaprogramming, since all the state transitions are already known before compile, so you can actually define those transitions already in your code using the template metaprogramming syntax, for example here, so that those transitions are already defined during compile time. This saves you the virtual function calls, and also it makes the syntax more meaningful for the readers. So this is quite fascinating, and although I have already 5 years of C++ programming experience, the metaprogramming world for me is still like a untouched territory. So I think many people have already known such kind of syntax. This is a templated function, meaning that the parameter of the function is templatized. You can pass in any type as long as a certain contract is being fulfilled. However, this is only a tip of the iceberg of the template metaprogramming world. So in this video, I want to introduce a bit more on the concept and the basics of the C++ template metaprogramming. Before, I think people are used to use C++ in this way, where we define a function and we can pass in a parameter, and we do some operation, in this case a plus 1, and we return the calculated value. So in this case, the input is a value, a number, and the return is also a value, a number in this case. And when we call this function, then we would call like this. So we call this function passing a number, and we get the return value. So this is a word that we are used to. So what is a meta function? Meta function is the function that is defined in the template metaprogramming world. So No longer we will take a number as input, but we will take types as input. And the output is also a type, which indicated by this syntax here. So to define a template, to define a meta function, we have one example here. So we have defined a struct called add_pointer, and for this meta function, its input is this input type here, and the return value is actually this type. And in this case, what we return is we return the pointer type of the input. So for example, if you pass in a int, I would return a int star, meaning a pointer to the int. So as you can see, this thing is all compile time ready. So we can make a very simple example. How will we call this meta function in the real code? So now let's remove the duplicated main. Okay, I think it wants me to return something. Okay, so here is how we call this add_pointer meta function. We call this function and pass in the parameter. In this case, as I said, it should be a type, and we pass in an int, and to get the return value, we have to type colon type, and we store the return value in another type, in this case pointer. Yeah, so what we are saying here that is actually we are saying the pointer that we get from this meta function has the same type as int star, and we are trying to use the isSame meta function from the C++ library. And in order to use that, you would need to include the type tray, right, and of course the assertion. Okay, let's see whether we can pass the assertion. Voila, everything is fine. So we actually get the int pointer as we expected from the meta function. You may think that this is a bit useless in this case, but actually there's this same function in the C++ standard library, and we can actually call it to see whether we get the very same result. So in C++, you have to call add_pointer from the standard library with the std namespace, and you actually use the very same syntax that I've used before. You pass in the int and the return value embedded in the type, and you get the return. So we can do the same assertion again just to check whether it does what we want. So we basically does the same assertion here. The standard pointer, we want it to be int star type. Okay, let's have a look again. And all right, nothing is wrong. Just in case that we are hesitating whether the assertion is working, let's make it deliberately wrong. So we say that the std pointer is actually an int. So let's see whether the assertion fails. Okay, it actually fails. So the assertion is actually working. It's pointing to line 26, and exactly it's this line. So if we make it back to star, then everything is fine again. So this is the very first video where I just did a very simple introduction for the meta function definition in the C++ metaprogramming world. And in the next video, I'm going to talk about more how to pass this meta function around, and it will make it more interesting. Thank you for watching.